My name is Wולkan Gerdon, and today we'd like to discuss about energy efficient heating systems in industry. And yesterday we also had another lecture, and there I showed the same page saying that the old people were really aware of what's going on. So that's an Indian proverb, so maybe it was Cherokees, maybe it was Sioux, I don't know, but they were said at that time, only when the last river is polluted, only when the last tree is cut, only when the last fish is caught, only then will they realize that you cannot eat money. And at that time it was really meaning about the white man. So, and they were saying that we are just finishing everything. First of all, I would like to briefly remind all of us once again that energy efficiency and energy savings are not the same, because they are always confusing each other. Energy saving is reduction of energy consumption, correct, by applying some measures which can end in losing some quantities or qualities even. So at the beginning you just say, yes, I will make my result a bit different than before, but at the end I'm going to save energy and save money. Energy efficiency, in contrary, means I'm going to do the same in at least the same quantity and at least the same quality, maybe more, and doing that I'm going to consume less energy. That's the main difference. Shutting off the lights in order to save energy is not always the correct way, but using efficient lighting in order to save energy is the energy efficiency work in everywhere, in any kind of facility. So first of all, in all the industries, we have to find out which one is important. For instance, if you talk about a textile confection, where you only sew parts together, where apparently the energy costs are not more than 3% of the whole cost. Or in another way, in, I don't know, cement or paper industry, where the energy cost might be as high as 55% of the whole cost. So therefore, entering a factory, first of all, we have to find out which one is important. Is 10% important for this factory, or is 0.1% important? So then we can start working in this factory. Many people are not so much aware of their losing energy or they are wasting energy. So if it's a tap, you hear it when it's leaking, but then you feel yourself obliged to do something. For many years, we were wasting energy, but we couldn't hear it, and we couldn't see it, and we were happy. Afterwards, somebody invented thermal cameras and start showing us that we are wasting it. So, I don't know if you can see it very well, but for instance, this is a header of a heating system in a factory. So everything looks fine, insulated. In reality, when we get a look in a deeper way, then we can see that there are points we are losing energy because of wrong connection of some feet to the other. Or when we look at another system, they are all insulated, but not the pumps. They said it's not so easy to make the pumps, but there we can see we are losing it. Here, a boiler. A boiler is a point where you can lose a lot or where you can save a lot. Here in this picture, even it's a good boiler or not, you can see there might be some losses. Or again, hangers of the pipes. Again, only by wrong installation, you saved the losses from the pipes, but you continue losing from the hangers. Or forget about thermal cameras. Here, that's a factory. We're using steam, and this white thing is what? Money. This is the money we are throwing out. Or in another factory, they use a lighting system. How good it is, can you see that? So cleaning can be a part of energy efficiency, because here every night, I'm sure this is going on. So getting through all the dirt and the insects in it and trying to enlight the area. And only cleaning would change a lot here. Yes, lighting saves a lot, but without changing I can save also. Here, it's visible, it's steam going out. When I asked this guy, he said, whenever the factory stops, I would change it. And then I checked that at least for 2 months it was the same. And factory stopping with me. So if you don't care about it, or here, a factory where they pop pellets. So then they put it in insulation materials. It's outside, and you can see it's over 1000 degrees. Uninsulated outside. There is no explanation why it is outside. There is no explanation why it is uninsulated. But continuously, he is losing the energy. That means we cannot anymore say, I was not aware, because every day we are seeing it, that we lose the energy. So, when people think about energy efficiency, we have to admit that we mechanical engineers are always thought in the second level. Everybody first thinks about electricity. In the reality, we know that in a factory, electricity and heat both are used. You cannot get rid of one of them. So you got to work on both of them. Because almost, not all, but almost all the electric consuming processes are also a kind of heat sources for us. Or vice versa, an important portion of electric consumption is caused by heat transfer or heat distribution system. That means whenever you think on both of them, famous word electromechanically, then you can create really big savings if you want to really reduce your energy intensity. Energy intensity is a very clear, bright picture of what you are doing. Country-wise, how much of energy you are using to produce $1,000 of product, national product. Again, company-wise is the same. How much you are using to produce $1,000 of sales revenues. When you make something like that, then you are going to find out that in the world, there are guys who are doing it really well. Israel is one of the good ones. On the other hand, Japan is creating the same $1,000 by consuming something like 60% less than you do. So in average, OECD has 0.17, while Germany can make the same $1,000, not another $1,000, with 0.11. Company-wise, you can make the same comparison, which will then definitely show you if you are good in it or not. Energy efficiency works always end with projects that we call energy efficiency increasing projects. EIPs, VAPs, there are different names for that. All these projects are about famous 4 R's, because all of them describe how to reduce something, how to reuse something, or how to recycle something, and mainly they are done by rethinking. We just clearly ask the guy who is doing the same for 30 years, we just tell me what you do, and then we find some good things that we can use. Because 30 years long, the priority maybe is not energy anymore. The priority can be sustainability. The priority can be problem-free operation. But looking from the efficiency point of view, the priorities we can change. So then we create projects. These projects we can gather under 3 main topics. They are listed in investment cost or easiness. But mainly the first group is the group where we almost don't invest anything. Maybe some trainings that we call optimization projects. We just optimize what is available. Pretend in an office you change the temperature by 1 degree only, and the result is at least 10 to 12%. Any investment for that? Nothing. Change the temperature setting. As an idea, optimization projects are as simple as these ones. Or the second group, improvement. Without changing the process, how to improve the efficiency. Therefore, the insulation of pipes are matching this idea. Pipe is the same pipe, system is the same, we just insulate or make a better insulation, and at the end the system is using less energy. And the third group is the bigger ones. That means we can create better efficiency results, sustainable ones. On the other side, there we are going to need more money maybe, which are going to pay themselves back. A good one can be an economizer after a boiler, where you can easily save 5% or more. So simple. Everything is the same. System is the same. Just one addition can change the story. Economize all the others. In industrial applications, we follow heat recovery. Heat recovery is, as you all know, taking the heat from somewhere where it was waste, excess heat, putting it somewhere else. It can be from heating to heating. It can be from cooling to heating. It can be discharge hot water. Before discharging heat, we can take out the heat. Ovens. There are plenty of applications in ovens, drying ovens or cooking ovens also. Condenser return of the steam system. It is still hot. Why not using its energy? Boilers, flue gases. So there are multiple topics about heat recovery in industrial applications. Again, for instance, economizers. You have a boiler, you are running it for 10 years, I don't care. Behind it, we just apply one simple heat exchanger, and at the end you start saving. What is this heat exchanger doing? This heat exchanger can preheat whatever is used in the boiler. If it's a steam boiler, you can preheat the fresh water. If it's, I don't know, you can heat any water or any other fluid or any other thing inside of the factory. What I really facing problems to understand is Israel is not so far away from Turkey, and we both don't have so many resources, and we import all the primary electricity. So, a bit more light. No, more. Yes, that's it. Okay, thank you. So, you also import energy, oil, gas, everything. Unfortunately, until now, I haven't seen economizers by myself. I'm sure there are economizers running. On the other hand, there shall be more, because Europe starts with economizers. Today, buying a steam boiler without economizer is just like a joke, because it's all integrated. They are doing this way. So just by applying one simple thing into the same system, nothing new, only an addition, you can save 5% or more. You can add another one, another one, another one. Don't forget, flue gases of a steam boiler are high. Before throwing them out, why not going down with the temperatures? Because this is my money going out. I can easily implement an economizer. And economizers are valid for gas, mazout, diesel, all kind of fuel can be used in economizers. Different designs maybe, but the result is the same. Ovens. In factories, in industry, ovens are widely used. Ovens can have different solutions for energy efficiency increase. An optimization project can be decreasing or changing of temperature. I can remember one application. The guy said for this they were just, it was about textile things, and they were drying them, and they were needing 110 degrees. Then we see that it was 130 degrees, and the question was why, if you need 110, why do you increase the temperature 130? The answer was to make sure.